Looks like we're live. Hello everyone and welcome to yet another Azuzin session. Let's make a little bit of an announcement and officially start the stream. So what are we doing today on a twitch.television website? It's a rather interesting question. Red Circle live on Twitch. And today we are developing a simple C/C++ Lexer to syntax. Why does it say 2? It's supposed to be 4 syntax highlights. Okay, so let me quickly fix all of that shite. I don't speak English anyway. English is my like 69th language, so I don't really speak it well. So yeah, I'm gonna give the link to the place where we're doing all of that, twitch.tv/Zozin, and I'm gonna ping everyone who's interested in being pinged. There we go, the stream has been officially started. So today we continue developing Dead, which is a dramatic text editor that we started to develop some time ago. You can find it in here. I copy-pasted the link in the chat. Or for people who happen to watch this chat on YouTube for whatever reason, it is going to be available in the description. So let's take a look at this thing. Dead. Dead. Let's take a look at the status. Status is clean. Let's fetch some latest changes. I wonder if I did anything off screen. I think I did something off screen for this text editor. I actually didn't. Okay, so that's fine. So I was slacking, mother flipping slacking. All right, so this is the text editor. This is how it looks like. And the point of the editor is that it's very dramatic. As you start typing things, you know, the camera action kicks in and it just like follows your cursor and it's just like, holy fucking shit. Right, so recently we started to support a selection, which doesn't really do anything except selecting the text. You can't select the text and copy paste it yet, but we have a mechanism for selection. And one of the important things that we did on the previous stream, on the very previous stream, is that we tried to implement a syntax highlighting. So you can do shit like int, and it highlighted it, int main, alright, and then you can maybe write a for loop, right? You can iterate something with a for loop if you want to. Right, let's put it this way. Right, so this is going to be another one, and so on and so forth. And as far as I know, we actually like hard coded like all of these C/C++ keywords. So I'm pretty sure it can recognize things like template, right? So can I put template in here? Yeah, it does recognize it. But there is a little bit of a problem, and the problem is the way we actually handle all of that. We handle all of that in a very dumb way. Right, we look for substrings of keywords, meaning that if I have something like forward, for is going to be highlighted as well. Right, so the problem here is that the text editor does not tokenize the keywords properly. Right, and the topic of today's stream is going to be actually implementing a small subset of the C tokenizer, right, of a C tokenizer, so we can highlight things properly, right? And since we're going to be able to actually classify different tokens differently, maybe we'll be able to even highlight them differently. So yeah, that's going to be very interesting. So yeah, that's the topic for today's stream. So we're going to implement like a simple C tokenizer, which goes through the entire text and groups the sequences of characters according to their class, according to their like token kind. And then I suppose we can pass that information to the renderer, and the renderer is going to look at those tokens, and depending on the kind of the token, it is going to just color them differently, right? Or maybe it's going to even apply some special shaders, right? So we have the cool thing about the renderer for this text editor is that the renderer can do shit like that. Right, so you can apply shaders on the text that you're rendering. So maybe the renderer is going to look at the kind of the token and is going to render tokens with the rainbowish color, like for example for types or something like that. Or maybe it's going to be custom thing. Maybe you'll be able to customize what kind of shaders to use for certain keywords, right? So that sounds actually kind of cool, right? Imagine like defining like a text editor theme, not in terms of like the token color, but token shader. I think that's kind of cool. So that's going to be basically the idea. So we could have just tried to use existing C tokenizer, right? But before using an existing C tokenizer, we have to ask ourselves a question. We just want to highlight some shit in a text editor, in a shady toy text editor. Do we need an entire standard compliant tokenizer to just highlight some shit? You know, the military grade standard compliant tokenizer just to highlight some shit. It's like, we probably don't. It's like, imagine like trying to implement like a pixelated Flappy Bird without any effects or anything like that and using Unreal Engine. It's like, yeah, I guess you can go ahead and use military grade game development. What the fuck am I saying? What the fuck is a military grade game dev engine? It's just like, what the fuck is that? But yeah, you can try to use that, but I mean, you probably don't need even 99.9999% of the shit that is in Unreal Engine just to do that. So yeah, you just probably don't need to do that. And my point is, we're gonna implement like our own tokenizer. Which is like a small subset of standard compliant tokenizer that is sufficient enough to just highlight some things in a toy text editor, right? So, and the cool thing about implementing your own tokenizer is that it's completely customizable, meaning that you can couple it more with your renderer. Right. Imagine that you're using an existing tokenizer from, for example, from STB. Right. So there are already readily available tokenizers for C, and for instance, from STB libraries that you can just use. But one of the advantages that we're going to have, we'll be able to maybe store in the tokens some additional information for the renderer. For instance, I have the following idea. What if we take the text and pass it through the tokenizer, and tokenizer gives us the sequence of tokens. But on top of the sequence of tokens, each token contains its kind and its text. On top of that, the tokenizer can also decide where physically, in a continuous two-dimensional space, that token goes. Right, because it kind of knows where it goes. It may know the dimensions of the font and stuff like that. But while tokenizing, it can actually compute the layout where it's going to be located. So each token also contains X and Y in floats, where the token goes. And then the renderer just takes the stream of these tokens. It already has the text, it already has the positions, and what it does, it just renders them. It just says, okay, so here's the tokens, just place that token in that specific position that the tokenizer told me with that specific color. So it's actually super easy because we control everything, right? So we can tie the different components of the system a little bit better to make our lives a little bit easier. So that's basically another reason to implement our own shit. Anyway, so we got a couple of subscriptions while I was talking nonsense. Thank you so much, MXViz for 9 months of Twitch Prime subscription with the message C++ in the title progress. Yeah. So just by supporting C++ keywords, I have an opportunity to put C++ in a title and then debate all of the people who will come to my stream, see the C code and tell me that this is not C++, even though I was not saying that I was programming in C++, but on the internet, people don't have reading comprehension enough to understand that. Anyway. So, and another subscription from Elimin0216. Thank you so much for 12 months, a year of tier 1 subscription with the message, Underkill is better than Overkill. Right, so it's like, it was spelled in a programish kind of way with greater. Underkill, maybe it depends on how much you underkilled and how much you overkilled. All right, so with the ready solutions, right, if you are underkilled and implemented your own solution, it is quite easy to just add a little bit more to make it less of an underkill. If you underkill too much, it's kind of difficult to do that, but if you underkill but a little bit, it's super easy to just add more. But if you used a ready solution and you overkilled a little bit more, how easy it is to get rid of that overkill? well, you have a library, which is a black box. You can't really change it unless you just make a copy of that library, but then you will have to port all of your changes to next releases of the library. I don't know, it's kind of difficult. It all depends on the specific situations. People want like a universal solution that works everywhere, so they never have to think and just follow the dogmas. It doesn't work like that, I'm sorry. You have to take a look at the project and see, does it work for that specific project? I'm sorry, you have to use your brain. Sorry to tell you that, people. But you have to analyze each situation differently. I know it's boring. I know it's difficult. I know it's easy to follow some paradigm, but it is what it is, and it isn't what it isn't. Surely you can just solve a problem once. Surely, Kappa. All right. Anyway. So let's go and try to implement the goddamn tokenizer. I have no idea how to implement the C tokenizer. I never implemented a C tokenizer in my entire life. So I'm going to be trying to implement a C tokenizer for the first time in my life right on the stream. Right. So, but here's the thing. I implemented like a lot of different tokenizers before, so I kind of know the drill. So yeah, we'll see how it goes. Let me see. Interestingly, so what we're gonna start with, I suppose we're gonna start with maybe Lexer. Let's just call it Lexer.h. I'm not gonna say that it's some sort of specific Lexer. It's gonna be maybe abstract Lexer that is going to work only with C, but maybe later we're gonna abstract it out and it's gonna be a general Lexer that can be used for like any language, because the editor probably gonna support like several languages or something like that. Okay, so if not defined Lexer.h, we're gonna define that goddamn Lexer.h and then and if, and this is gonna be a comment. So let's define different kinds of the token. So this is gonna be a token kind. What kind of kinds do we want to have in here? I suppose my favorite token kind is more of a like token end, right? So this is essentially the token that is returned at the end of the stream, right? So you consumed all of the tokens, and the last token that the Lexer keeps returning to you is the end, right? So it's quite convenient to have such token. So another token that we're gonna have, let's take a look at the C code, right? So the first C code that we usually have is it's usually some preprocessor shit, right? It is usually some preprocessor shit. And I'm thinking, right, in a preprocessor, do we tokenize the preprocessor? I think we should try to tokenize the preprocessor. Right. So maybe we're gonna have a token token pound, right? So what is the name for this sign? I think it's a pound or something, right? So it's a hash pound or whatever. Right, and another common symbol that we can have in here is some sort of a symbol, some sort of a name. Right, so let's actually call it token symbol. Right, and let's just start with these kind of tokens, and then we'll be able to extend with more. Hashtag. I think it's like, I feel like it depends on the English, right? So in American English, I think it's pound. In which English it is pound and in which one is it hash? Like I don't remember. Like I don't speak English at all. So I suppose I heard Casey calling it pound, but Casey is American. He speaks Americanese. So in Americanese, as far as I know, it should be and then pound, right? It depends on the context. Okay, I see. At least here in Texas, you can call a pound or a hash. Oh, okay. So just like, yeah, in different parts of America, you can also call it different one. Okay, so I'm gonna call it hash because I'm an internet person and everyone on the internet calls it hash because of Twitter. Because Twitter is cool. Am I right, kids? Twitter is cool. It's hip and cool. Sorry. Okay, so we're gonna have the token, right? We're gonna have a token, and we're gonna also have a token kind. So, but on top of that, we also need to have the text of the token, right? So we're gonna basically store the text of the token in a sized string, because usually you have the content, which is the entire string, and token is a substring. And token, like, I like to program the tokenizer so the tokens don't own the text and they are just like having references, and because of that it is easier to store them in a size text. Right, so then on top of that we're gonna have a text len. As you can see, it already auto-completes. It suggests me to call it a certain way that I would like to call. It's almost like GPT. It's almost like a GPT model of some sort, like a Copilot or whatever it's called these days. I don't know. But what it does, it basically auto-completes the existing tokens in all the open buffers. So yeah. Anyway, and it's almost like Copilot. Now, what else do we have? I think usually that is it for me, but since we're preparing the tokens for the renderer, I might as well also provide something like a position, right, position on the screen. Also, yeah, I forgot a very important thing. I also have some sort of a thing called location, right, which denotes where exactly it is located within the text. Usually it is needed for reporting purposes, right, for some sort of reporting purposes where you specify the file path, where it is located, right, and then row, and the column. But here is an interesting thing. I don't think for syntax highlighting I need any of this information, actually. Right, so I'm not going to report anything. Like, why do I need to know the row? I kind of need to know row and column so I can render it properly. But then I can like straight up specify the position on the screen. So this is not needed, at least right now. I don't see any use for that, but if I will have some use for that specific tokenizer, I may add it. But right now it feels like if I just preparing the tokens for rendering, I kind of don't need this usual information that I put in the tokens when I'm developing, for instance, interpreters or compilers. So I'm doing that purely because I have a reflex, right? So I developed interpreters and compilers and parsers, and usually I need to report errors. Here, I don't think. Yeah, here's an interesting thing. If I have some sort of like a tokenization error, I'm probably not gonna even stop tokenizing. I'm probably gonna just like skip an invalid token and continue tokenizing, right? Because I don't want to break the highlighting or something. It's actually kind of cool. So tokenizing for syntax highlighting is kind of different than tokenizing for parsing, right? So for different purposes, you can just actually tokenize things differently. That's so cool. And that's another reason why to write your own tokenizer for syntax highlighting, because who knows for what kind of purpose this tokenizer was implemented for. I'm pretty sure this tokenizer was implemented for code generation, for analyzing C code and some code generation. It may work for your case, but there's always going to be a little bit of like a misfit. Right? Every time you take a component and it doesn't fit quite well to your purpose, you pay a little bit of a cost. Right, because you always have to adjust, maybe break some parts around just to fit that component in there, right? So always like pay a small cost. You may say that it's a very small cost, but it accumulates over time. And nobody thinks about that, actually. Nobody really thinks about that until it's too late. Until it's too late and it's impossible to rewrite your project from scratch. You know what I'm talking about? You know what I'm talking about. Anyway, I'm sorry, I'm talking too much today. Okay, so this is what we're gonna have in here. So just the token, the kind, the text, the position, and stuff like that. Right. So, and usually I have the structure that keeps track of the current Lexer state, right? So usually we have something like the content. So it points at the beginning of the content of the entire thing that we're trying to parse. Then how much of the text, right? So basically how much of the content we have. But I already call this thing len, so maybe I'm going to call it a content len. All right, and usually in C specifically, I like to keep track of the cursor, right? So where it is located right now, right? So the position of the thing. Maybe we also need to keep track of the current line, right? So where on the line are we located, right? Because since the Lexer is also going to define the position where the token is going to go on the screen, it kind of needs to know on which line we're located so it can calculate the location properly. Right. So cursor is actually absolute position. It is absolute position. Line is just the line. Right. We don't keep track of the row. Instead of keeping track of the row, I usually keep track of this something called beginning of the line, right? And if I want to know the row we're currently located at, right? So if I have Lexer like this, I need to know the row, the column. The column is going to be equal to the Lexer cursor minus the beginning of the line. That's how we usually do that. I don't really store the column where we're currently at. I only store the cursor, which is absolute position, which also may point at the new line and stuff like that. And I also keep track of the beginning of the line, right? And every time the cursor encounters a new line, what I do, I increment the cursor, save the new line, and increment the line. Right, so I can treat the stream of characters without thinking about the lines, but every time I encounter a new line, I just increment and update these two values, and having these two values allows me to also keep track of the column as well. Does this make sense? This makes sense. I'm not really sure if it does, but I stole this idea. It's not my idea, by the way. Doing it like that in Lexer is not my idea. I stole it from a camel's Lexer. Believe it or not. One day I was actually going through like a camel's Lexer or something like that, Lexer ML. I don't remember where I saw that. And they were literally doing that. So there was a definition of the Lexer structure that they use. And they were doing that. But I'm not sure if I can find that. Right. Okay, I'm not sure if I can find it right away, but trust me, I stole that idea from a camel. Usually if I steal idea, I like to credit the places from where I stole all of that. Right, so yeah, I stole that from a camel. Isn't it cool? Isn't it cool? Because I used to actually store just column and line instead, and it was a huge pain in the ass to keep track of the things, but this one is a little bit easier. Anyway. So what else do we want to have? We probably want to have some sort of constructors, right? So we want to be able to construct a Lexer. Let's create Lexer new, and we're going to only accept content and length, and everything else is going to be automatically initialized for you, I hope. Right, so size t content length. Right, so it's going to be that. And what's going to be the next thing? We're going to have Lexer next, which should return the next token, right? Which should return the next token. And let's actually try to do something like token. We're going to provide the pointer to the Lexer, and that is it. I'm not sure if we want to have any sort of like error reporting, because what kind of error are you going to report? You encounter an unknown token, and what you're going to do about it? You're going to cry? Piss your pants, maybe? Maybe I know there's nothing you can do about that, right? So you maybe maybe we're gonna have some sort of like a token invalid, right? Token invalid, and then the how to say that, the renderer can maybe highlight it with red or something like that. Okay, so something like this. Do we need anything else? I don't think so, right? Okay. And how are we going to be rendering all that? So you know what I just thought? We can probably tokenize all of that on every frame. Is that a bad thing to do? Like, because you're going to have a text, and it's probably a bad thing to do. Yeah, if we never change the text, maybe we never have to tokenize anything, right? So you can just cache the tokens, all of the tokens, and every time you change the text, you recalculate all the tokens. It's kind of similar to how we compute the lines in the editor. My God, it is, yeah. The lines recomputation is basically tokenization, but by lines. That's cool. I think that is very fucking cool. Yes. So it's basically, you can tokenize text differently, right? Depending on your purposes and stuff, on your goals, not purposes, goals. All right, so Lexer.c, and we're gonna include Lexer.h. And let's go, and let's just do that. Okay, so I'm gonna create Lexer. Maybe I'm gonna zero initialize this entire thing, and I'm gonna set the content to content, right? Content to content, and then content length, and just return L. So everything else is gonna be zero initialized, and this is exactly what I wanna have for now, at least. Right, so in here, I probably want to create the token that I'm about to return. So initially it is going to be zero initialized, and then I'm going to just simply return this thing. Depending on different situations, we'll be able to set the token kind to different things, but for now it's going to be that. And what's cool is that end is zero, so it means that if you just create a token structure with zero, right? So zero initialized. That means that token points to the end, right? So which is a sensible default in my opinion, right? But for now, I'm gonna say unimplemented Lexer next, right? So and this thing is, well, it is used, but I can say that this thing is in use for now. All right, so let's actually add all of that stuff to the building, right, to the building process. Otherwise, we won't be able to even know whether this entire thing compiles or not, right? So let's have Lexer.c, and let's try to run build.sh. All right. So size t doesn't know what is a size t. As far as I know, size t is defined somewhere in the std_def, right? I mean, why did I put define in here? I need to put include. What the hell is going on? So this one is no process. I think it's just something weird. What else do we have? A vector for position. Okay, so this is located in linear algebra module, so I'm going to include that as one as well. It's kind of weird. The tokenizer that also uses math, right? So continuous like 2D graphics, which is, I mean, it's not that bad actually. It's not that weird, right? Because tokenization is like a very abstract process. It's a process of just grouping characters and classifying characters for a certain purpose, right? Who said you can't really attach additional information to the group of the characters? For example, position on the screen, right? So who said you can't do that? You can't do that. All right. So everything seems to be okie dokie and maybe even a karaoke. Right. So the first thing before doing any sort of tokenization, right, we want to do is basically get rid of the white spaces, right? So let's maybe create something like Lexer trim left. So, and essentially this is going to be a function that simply keeps removing the white spaces until it hits something that is not a white space, right? Lexer trim left, Lexer like this, right? So this thing is unimplemented. Lexer trim left. There we go. And what we're gonna do? Like after we trimmed all of the white spaces, and there is a very weird situation when the cursor, for some reason, is greater or equal to the content length. What does this mean? What does this mean? That means we reach the end. So, and the only sensible thing you can do in this case is return a token, right? So we also set the token to be like 0 at the beginning of this entire, endeavor. And that actually works out naturally. Why? We didn't have an opportunity to even classify the token somehow, so we just said, okay, so it's just end of the stream. But on top of that, it would be kind of nice if the elements of the tokens, right, things like text and text_len, were actually pointing at the end of the stream, like they were actually correct pointers, and if I did something like text -1, it would point at the first character of the content. That would be kind of nice. So it's not on the end, it actually points at the memory after the end. So it's kind of cool. So maybe before doing all of that, right, so we trimmed everything, and then we say, okay, text starts at the content cursor, at the content cursor. This is where it starts. We don't really set the text length yet. It is 0 for now, but we can update it as we go and tokenize things, right? So initially it doesn't have any kind. Well, initial kind is end, but it's kind of a default value. It points at the thing after trimming at the first non-zero character or end of the string, and then if the cursor is greater, we just return that, and it just like has sensible values. I think it's kind of cool, maybe. So after this entire stuff, right? After all these entire checks, we are 100% sure that the cursor is less than the content length. It is less, which means it is absolutely safe to do something like this. Absolutely safe. It's so safe it feels like you're programming in Rust. That's how safe it is. I'm joking, by the way. So the memory actually with the Lexer can be corrupted, and you may end up with incorrect pointer in here, and it might be actually not safe even if this condition is true, right? So never feel safe. That's what I'm trying to say, right? So always be ready that something's bad's gonna happen. Anyway. So, well, what kind of tokens do we even have in here, right? What kind of tokens do we even have in here? We defined a hash, right? So how can we define a hash? Okay, so if this character, if this thing is equal to the hash, well, we can just say, okay, token kind is equal to token hash. Isn't that cool? And what's the size of the token? So what's cool is that the text of the token already points at the right place. It already points at the right place. We don't have to do anything, but we know that the token hash is like a 1 character. So that means we can say, okay, text len is equal to 1. And that is basically kind of enough, almost. One of the things we have to do, we kind of have to consume that character, right? We have to consume that character and increment the cursor by 1. Right, we have to increment the cursor by 1, and then we can just return the token. Right, then we can just return the token, and there we go. We successfully tokenized the thing. Right, we successfully tokenized the thing. So interestingly enough, just incrementing cursor by 1 is kind of dangerous, right? Because, well, I mean, it's actually kind of fine. Right, I was thinking about what if you encounter new lines somewhere there, but the new lines should be handled by trim left. Right, new line is a space, right, so it should be handled by these things in here, so it should be fine. Okay, so what other things do we have? We have symbols, right? So we need to decide what are the symbols, right, in C. The symbols are things that basically can be used for keywords, for names of the variables, names of the types, names of the functions, and so on and so forth. Right, so C symbol, okay, valid symbol names. Is that a thing that we can Google up? What is a valid and invalid C variable names? But it's not only for variables, actually, right, it's kind of similar. I forgot that Quora, out of all things, Quora is banned in my country. I completely forgot about that. I have no idea why. Our government is insane. They're just banning like all this shit. Okay, so let's actually go to Microsoft. And Microsoft is not banned. Would you look at that? Microsoft is not banned, but Quora, for whatever reason, it's banned. It's for no idea. Somebody left a comment that our government didn't like on Quora, right? ChatGPT banned. Well, ChatGPT is banned by ChatGPT, but Quora is banned in Russia, right? So there's a kind of a weird situation where like half of the sites are banned from within, and half of the sites are banned from the outside. And it's just like, okay, it is what it is, and it isn't what it isn't. All right. Truly sad game. Okay, so what are the valid identifiers? Do we have a simple rules? Like, I know the rules, right? You know the rules, and so do I. But I just want you to have the, confirmation, right, somewhere from the from some sources or something like that. The rules are the following, right? So the names may contain alphanumeric values, basically English letters and numbers, and also underscores, right? And they cannot start with a number. They can contain number, but they cannot start with a number, right? They can contain, but they cannot start. So, and the reason is probably because of the scientific notation, right? So, for instance, this is a number, right? It may feel like a name, like at least this part, because it contains a character, but this is a number, and it's indicated by the fact that it starts as a number, right? Because a number literal may contain characters. Another one is a hexadecimal value, right? Something like this. This is a number. It contains a letter, right, but it's not a variable name, and it's indicated by the fact that it starts with a number. So this is kind of like the rules. So there is a difference between a name that contains a character and actually valid variable name. So we need to separate maybe symbol start and just a symbol. So I want to have two functions, like is symbol start, right, and we can accept a character, right, so something like this. Unimplemented, right, is symbol start, right, and is symbol, which is going to be this, right, is symbol. So when a symbol start is going to be is digit, right, so it's is digit. I think I can just use is alnum, right, which basically includes letters and digits. Alnum or underscore, right. Actually, wait, is alpha. I'm sorry, I'm an idiot. I just explained that it can start with the characters and stuff like that. Right, so alpha or equal to underscore, but it cannot be digit. So the symbol, right, the symbol in here is alnum. Is alnum. So yeah, it's kind of interesting that they have like the same length, right? They have the same length, and it's easy to confuse them. The only difference is just these three characters, right? Alpha and num. Okay. Anyway, so essentially, what we want to do, if el content, so I'm speaking Spanish right now, el cursor, el content, el cursor is symbol start, right, is symbol start, we need to basically keep consuming the character. This is actually kind of cool, because essentially what I can do now is while el content, el cursor is symbol, right, while it is a symbol, I can simply increment the token text, el contento, yeah, exactly, the token text length, and also the cursor, right? So the cursor, I increment the cursor and the text, but most of all, I have to also check that this thing is less than the content length, right? Than the content length. While it is a symbol, I just advance the cursor and I also increment the size of the token. I also have to set the kind of the token to the token symbol, right? So this is a token symbol, right? And after we reach the end, right, after we reach the end, I can just return that specific token. And there we go. So we now can tokenize the end of the stream, right? So the end of the stream, the hash signs, and also the symbols. So that means effectively we should be able to tokenize at least include, right? So we're going to have two separate tokens in here. This, the hash sign and the symbol. So after that, we have some sort of like file path, right? So we have a file path. And what's interesting is that it only makes sense if you are in some sort of like a preprocessor mode, right? If you are in preprocessor mode. And maybe this is what Tokenizer should be able to do. It should have a mode. Are we right now in a preprocessor mode? If we are in preprocessor mode, we're gonna treat this as a string, right? If we're not in preprocessor mode, we're going to treat it as like a different thing. So I wonder if the modern C compilers do it like that, right? Because in the old days, there were always two programs, the preprocessor and then the compiler. So you pass the code through the preprocessor first, and you get the C code without preprocessor stuff. And then you have a compiler, right? But as far as I know, these days, at least I looked into compilers like TCC, like a tiny C compiler. This compiler doesn't really distinguish between preprocessor and compiler. It's like 2-in-1, right? And essentially, it expands the preprocessor tokens as it compiles. Like, it doesn't care. It's a compiler and preprocessor simultaneously. So the first thing it does, it takes the token and it expands the token until it reaches the end of the expansion process, and only then it considers the next token, and then it proceeds compiling. So it sort of preprocesses things lazily, right? It preprocesses the tokens as it goes, and there's no really separation between preprocessor and compiler in TCC. I looked, like, I know that because we hacked TCC at some point, right? I wonder if you guys remember that, but yeah. So, and to achieve that, I suppose you need a special tokenizer that can have several states, right? So as soon as it encounters this thing, it goes into the preprocessor state, right? And it starts to return different kinds of tokens, right? For instance, it can, if it encounters hash, it goes into preprocessor mode until it encounters the new line. After that, whatever less or greater symbols you put in here are going to be interpreted as less or equal. You know what I mean, right? So unless you put a backslash in there. If you put a backslash in there, so go into the new line, it's still going to be in the preprocessor mode, so it's going to tokenize things differently. You know what I mean. Though, interestingly enough, you can still have less or greater in here in the definition, for example, when you do define, and it's going to be fine, I guess, which is kind of strange. So it raises the question, how exactly does it tokenize those things? But I suppose it doesn't really matter. We'll see, we'll see. It's kind of an interesting thing. It's kind of an interesting thing. Right, so the problem here, though, is that I ran out of T. So it's kind of difficult for me to think of a good solution. So we probably need to make a small break. And after the small break, we're going to think how we can do all that. Okay, so I think I want to maybe check how this entire tokenizer works. I think that will be kind of interesting, I think. But it's kind of not really easy to check it for now. Right, so because we have some things that are not implemented. So let's actually go ahead and just do it like this. So this is main, right, so let's create an alternative main. Let's say that we're going to have some sort of a content in here, which is const char content. And so for now, we only support hashes, right? And yeah, there we go. So hash include. Maybe we're going to put another hash in here, right? So let's go ahead and create a Lexer out of that. Lexer new content strlen content, right? So this is going to be that. And essentially what we're going to have, we're going to have a token, right? And then I do t equal Lexer next, right? And I keep doing that while t kind is not equal token end. Right, so we keep pulling tokens out of these things, and let's see what we can have in here. We can try to print the token somehow. So let's say that we're gonna have something like a token kind name, right? We want to be able to convert like a token kind to a name, so we can display that in here. And after that, I think that should be fine. So this is how we're gonna be you know, lexically analyzing this specific string. Right. So it would be also nice to print that string here somehow, but I don't remember how you print sized string with PrintF, right? PrintF sized strings, because it's kind of weird. You have to put like a star in here and dot here, but I don't remember, do you put dot here or here? It never makes sense to me. Like I can never remember. It's such a weird way of printing size strings, so I always have to Google. It doesn't have any sense. Doesn't make any sense. Okay, so you have to put dot first, right? So you have to put dot first. So text, and then you have to provide the text length, right? So text length, and the text length must be integer, not size. Right, so it is integer, which meaning that it can be negative for whatever reason. I don't know why, but it can be negative. Sure, and that should be enough. So we're also going to wrap this entire thing in parentheses to separate the actual text from the kind of the token. Right. So let's try to compile this entire thing and see how it miserably fails. Right. So what do we have in here? We don't have a Lexer because we need to include the Lexer. Lexer.h. There we go. So what else do we have? We don't have a token kind name. Let's actually introduce that. Okay, so where is the token kind? There's the token kind. It's going to return const char, and we accept token kind Lexer.c. So let's maybe put it somewhere in here, and now I can do something like this. Switch kind, boom, then boom, case, this, return, boom, boom, boom. So in case of default situation, we're going to say something like unreachable, right? So unreachable. And there we go. That should be enough, I think. So in here, we can just return maybe null. Let's return null. In case we're going to try to print this entire thing, it should segfold. But it should be unreachable, in my opinion, right? It should be definitely unreachable. We can even put some sort of a message in here. Token kind name. So end of what? End of stream content. Let's call it end of token. End of content. Invalid token. Hash sign. So this is a hash sign symbol, right? So this is kind of stuff. So token kind name. Right, so if we try to compile that, it should complain about unreachable because I don't think we have unreachable. Or do we have unreachable? I don't remember. Okay, so yeah, we don't have unreachable. Unreachable should be easy to implement. Right, so we have things like unimplemented. Right, so let's introduce unreachable because it's kind of simple, similar. It's just like a different text. Unreachable. Yeah, and let's also realign backslashes. God damn it. God fucking damn it, meat. Okay, I'm sorry. So it complains about is alpha, but this is because we didn't include C type. It also complains about boolean. So it wants to have something like std boolean, right? Std bool. Std boolean. Okay, so we also need to include C type. Cool, so it compiles. And if we try to run this entire thing, right, so this is going to be that, and it says Lexer trim left is unimplemented, and we can go here and implement it. So how are we going to be doing all that? All right, so while cursor is less than the content length, right, and content L cursor is space, while it is space, we simply increment the cursor. That is it. It is as simple as that. While we have some characters in a content, and those characters are spaces, we just remove those characters by advancing the cursor. So basically cursor plus 1 is just consuming the character. But interesting enough, what if that specific character is a new line, right? What if it's a new line? This one is rather interesting, actually. So if it's a new line, we have to update our current line and the beginning of the line so we can compute things correctly. And I'm not even sure, as I already said, that we do care too much about beginning of the line. Maybe we do actually. Yeah, So because we need it for the position and stuff like that. Right. So essentially, if the content, not just a cursor, but also a new line, right? Before incrementing things, we also have to increment the line, right? So on which line we are, we start with a 0, now it's 1. And then, right. And then we have to assign a new beginning of the line. But here's the interesting thing. So we have this situation, A, B, C, D, and then new line. Right, so currently the cursor is at the new line, right? We're currently at the new line, right? But we need to, so and this starts another line, right? But the beginning of the line has to be the next one, right? It has to be the next one. So that means this kind of condition has to be checked after we incremented this thing. So we may do something like character X, just save this entire thing in here. Then increment the cursor, and if it was a new line, we're gonna increment the line, and also we're gonna set the beginning of the line to the new cursor, like so, something like that. Right. It may evolve into something interesting in the future. We'll see how it goes. Right. So this is something that we have in here. Okay, good. So let's rebuild the entire thing. And it keeps printing hash sign. Isn't that cool? Isn't that cool? I think it's pretty cool. So it keeps saying it's a hash sign, it's a hash sign, it's a hash sign. Let's find out why is it keep saying something like that. Right. Right. We incremented the thing. Right, we incremented the thing, and that should be fine. I don't see any problems with that. Right. So it may happen because of this. If we forgot to put +1 in here, but we didn't forget to put this one in here. Right. We didn't forget to put +1 in here, so this one might be kind of weird. This one might be kind of weird. So maybe on top of that, after we... Oh yeah, I know why. Because we never actually get the next token. Yeah, I've completely forgot about that. You have to do next token in a loop. There we go. So this is what we have. We have first hash sign, then include as a symbol, then a hash sign again. Right. Interestingly, as I already said, because of the way we tokenize, it doesn't really matter how many spaces we have in here, right? None of that matters. If you're gonna retokenize this entire stuff, it's still going to be hash sign, symbol, hash sign, right? We can add another symbol in here, another valid symbol in here, right? And it says include foo, and it sees it as two separate symbols. But again, if I remove white space between them, it is going to be considered one symbol again, right? So this is like sort of the nature of the tokenization. You know what I mean? It's the nature of the tokenization. Right. So, and we can tokenize this kind of stuff. Isn't that cool? So I think we don't handle invalid tokens, right? For instance, if I have something like include, right. So let me see. Something like stdio.h, I don't think it's gonna work properly. Right. Yeah, Lexer, yeah. That's actually kind of cool. So it basically went through all of the conditions in here, right? And it didn't recognize any of the existing tokens, right? It didn't recognize any of the existing tokens. And then we hit unimplemented. Okay, so here usually what I do, I report an invalid token, right? So if we reached this point, this is an invalid token, token invalid. Okay, but here's an interesting thing. What we can do, we can actually set the token text length to 1, right? And say, okay, we encountered a known token. We don't know what the fuck it is, right? We're going to report it as a token of a symbol 1, hoping that the next token, the next character starts with a valid token. You know what I mean? We can try to do something like this. And let's try to recompile this entire thing. And it keeps saying in invalid. And one of the interesting thing I forgot is to also consume the token, right? So el cursor is going to be +1. Yeah, so that's kind of important. And now we can see how exactly it tokenized this entire thing. Right, so first it found a hash sign, right? It is correct. It is a hash sign. Then a symbol include, like this. Then invalid token, this thing, right? And then it found a symbol, so it recognized this thing as a symbol. Then it found another invalid token, right, which is dot, then a symbol, and then another invalid token. So we can handle it like that. I'm not saying that this is how we're going to be handling that, but for now, we can just keep it like that. So if we went through all of the checks, if we checked for all of the possible tokens and we couldn't recognize that token, we just take that character and report it as invalid token. So maybe the renderer is going to render it with a red sign, telling you that, like, I don't understand what the fuck did you just say, correct that, right? You know what I mean? You know what I mean? So that's basically the idea. That's basically the idea, but specifically shit from the preprocessor, right? So the thing with the preprocessor are a little bit finicky because the tokenization of preprocessor directives depends on the directives themselves, right? Because, for instance, if we're talking about directive include, it tokenizes less and greater as the beginning and the end of a string for the file path. Right, but if we're talking about define, where you define a certain thing, this thing tokenizes, you know, greater and less as tokens of C, because it's going to replace token foo with this sequence of tokens. So it not only depends on whether you are in preprocessor mode, it also depends greatly on the preprocessor directive itself. Different preprocessor directive are going to just tokenize things differently. Because of that, I want to actually sort of put the idea of tokenizing preprocessor on a back burner by doing the following hack. Essentially, if we encounter the hash sign, we basically take all of the characters up until the end of the line and report it as a single token preprocessor, right? Preprocessor, and then the render color it with a single color for now, right? So, and of course, it's going to be a little bit more, how to say that, more nuanced, because the preprocessor may continue working if you put backslash, because in the preprocessor you can backslash the new lines, right? So we're going to handle that as well. But in any case, everything that is in the preprocessor, we're going to say it's a single token, it's a preprocessor bullshit. Just color it somehow. And then we continue tokenizing as usual. So what's interesting is that in a similar way, we're going to be preprocessing, we're going to be tokenizing comments and strings, right? Because in comments and strings, it's kind of similar, right? Because if you encounter // it's basically, okay, take everything starting from // up until the end of the line and say, this is a comment. No matter what kind of shit do you have in here, do you have spaces, you don't have spaces, doesn't matter, single token comments. The same goes with the strings, right? It's just like you have spaces, don't have spaces, doesn't matter, everything up until the end, up until the double quote, it's a string, render it somehow, plus you may have situations when you escape some of the things, right? So it's like we're going to be handling preprocessor comments and strings in a similar way. But preprocessing handling is going to be like that for now. Just because I don't want to go into this weirdness of if we encountered include, that means we change the tokenization to that. If it's defined, change tokenization to that. I don't really want to deal with that. You know what I mean? It's just kind of like I can do that maybe later. Right? For now, I just want to have something working. Right. Alrighty. You know what I mean. You know what I mean, chat. Hopefully you know what I mean. Okay. So we have int, we have invalid. We're not gonna have a hash. We're not gonna have a hash. We're gonna have preprocessor, right? Maybe I'm gonna call preprop. So then we're gonna be able to handle the symbols and some other shit. Lego Megger, thank you so much for 5 months of tier 1 subscription with the message "Sup Zozin," a sup, hello, hello, really good to see. So do we have any other subscriptions? Okay, we don't have any other subscriptions. Preproc, yeah, but Preprop sounds funny. All right, so let's go. So if we encounter hash, what do we need to do? We basically need to start doing the following thing. Consume everything up until the end of the line, right? Consume everything up until the end of the line. While el cursor is less than el contento length, right? And el content, el cursor is not equal to the new line, right? We basically keep incrementing the cursor and keep incrementing the size of the text, right? So basically token text length +1. We just keep incrementing that. So, and of course, the token kind has to become preproc. That's it. So interestingly, we may have a weird situation that, yeah, so when we encounter a new line, we also have to update the beginning of the line and the line itself, so we know the coordinates where we're located. So that means now we have to do this thing in 2 places. In here, when we consume the preprocessor, and also in here when we trim the left white spaces. So I encountered this situation over and over again when I developed the tokenizers, and I came with a solution to have a separate function that consumes a single character. You know what I mean? So essentially Lexer chop, maybe char or something like that. Right, and essentially it's going to return the character. And what it does, it takes the current character, just chops it and returns to you. Some people suggest it, maybe it's it, but I like to call it chop. Right, so it's going to report the character to you, and it's going to increment the cursor. It's going to also update the line and the beginning of the line, depending on whether you encounter the line and stuff like that. So we're going to encapsulate this entire logic into a single function that just works with a single character, and we forget about it. Right, we forget about it. So it's going to be like that. So I think it's not going to be a responsibility of this function to check whether you reach the end of the content. So we're going to assert that the cursor is less than the L content, right? So it's like it's not up to this thing. Right. So the next thing, we can literally take actually this chunk of code and take it as an implementation of the function, believe it or not, and we can just return X. Actually, it works really great. It works really great. It's like the implementation of the function is literally this, right? Because we take the next character. If it's new line, we just update that, but we still return this entire thing. Right, and in here, what we're gonna do is, I think, man, this is actually kind of weird because I feel like the entire implementation is just Lexer, chop character L, and that is it. And the while loop is empty. You know what I mean? Well, probably not. Nah, probably not, because you don't want to do it like that, right? So essentially, you want to first check. Yeah, it's kind of dangerous. You check for that, and you just call, yeah, for this one, it's not going to work like this. Chop character L, right? But for this specific case, we don't really care about the result, right? So we don't really care about the result, so we're going to ignore the result. So sometimes to indicate that I don't really care about the result of a certain function, I just wrap it in unused. I'm not sure if it's it's sort of like I say that I know that this function is supposed to return something, but I don't care about it. No. It's just like, yeah. So for documentation purposes, like, yeah, I know it returns something, but in this specific case, we kind of don't care. We kind of don't care. All right. So what we're gonna have in here, essentially. So while this thing is not a new line, we're going to do the following stuff. Wait a second. Yeah, this is fine. So, and what we can do is just Lexer chop character, right? So this is a preprocessor. While we have something and that something is not equal to the new line, we're gonna chop the character, right? I don't care about the final thing of that character. And so we can have different situations in here. For instance, when we reach the end of the stream, if we didn't reach the end of the stream, we have a new line in here, right? We do have a new line in here, so maybe I'm gonna actually do the following thing. If this thing is still less than the content, I just do Lexer chop character, like I chop an extra character, right, which is not becoming part of the token. And the way it becomes part of the token, I also increment the text length. Right. So as I chop the characters, I increment the length, and after that, if we still have some characters, that means this thing is equal to the new line. So I chop this thing and automatically go to the new line, and so on and so forth. Okay, so that's fine. That is very, very cool. Right, so now let's go and try to recompile this entire thing. So now, if everything's correct, so token hash, we don't have a token hash, but we do have a preprocessor directive. So what else do we have in here? So we don't have an assert, and this is because we want to include assert as ert. Okay. And yeah, that's actually kind of cool. So this is the tokenization. It recognized this entire thing as a preprocessor directive. Easy tokenizer, by the way. Anyway, so what else can we do in here? Right, I'm gonna use the feature that I, hated C for. I'm gonna use the multi-component string literals because it makes it easier to do things like this. Right. So what if we have an actual code in here? So how are we going to tokenize this thing? All right. And let's actually 1, 2, 3, 4 return 0. Let's try to tokenize like a very simple C code. Right. So what we're going to have in here? So the first thing we recognized, we recognized a preprocessor directive. Then we recognized int as a symbol. Right. Then main as a symbol. Then we found invalid token, which is open parent. Then void symbol, invalid token, return symbol, invalid token, invalid token. Right. But it's working, right? So it kind of recognizes the main components of the C language, if you know what I mean, right? So it kind of like it's starting to make sense of this thing. So the next thing we need to do, we probably need to add support for open parent. Right, and then for closed parent, and so on and so forth. Let's go ahead and try to do that, right? So since we already have like sort of like a backbone of this thing, we can just like throw more and more tokens on top, right? So it's gonna be token open parent, right? There we go. Token open parent, and let's see what we can do in here. So token open parent. And we can say that this is an open parent. Not parent, but parent. And when do we encounter open parent? Well, when L content, L cursor is equal to open parent, right? When it is equal to that, we say that the token kind is equal to token open parent. Then we know that the size of this thing is in fact 1, right? It is equal to 1. And then we can actually increment this thing. And then we have to increment, we have to Lexer chop character L unused. So I feel like I'm constantly using unused. Maybe this thing should not return anything. And then we just return out of that, right? So there we go. Look at that. So it complained about something. It has to be equal, sure. It complains about something one more time, and this is because we have to return the token. Yeah. Okay, look at that. So let's open the code as well, right? Let's open the code as well. So the first thing we recognized is preprocessor directive, then a symbol int, right? So here is the symbol int, then symbol main, and then open parent. It is not invalid symbol anymore. Look at that. It is not invalid. And then we've got the void symbol, and then rest is invalid stuff. What's cool is that it doesn't really matter like what kind of white spaces you put in here, right? It doesn't really care about the white spaces. Like it literally doesn't give a shit. Right, so it's going to still tokenize it as usual, right? So we have an open parent and some stuff like that. So the next thing we probably want to do is to add a close parent, right? So let's go ahead and do that. So we just added a close parent. Believe it or not, it's as simple as that. And then I say, okay, close parent, let's find the open parent, where it is, where it was. I think it was something like this. And close parent is just basically copy paste this code, close parent, and there you go. Simple as that. Oh shit. And look at that. Close parent, open parent, close parent. And you just keep repeating process, you just keep adding tokens. Just keep adding tokens. Which raises a very interesting question. Like, isn't that like a lot of copy-paste code? Right? Isn't that a lot of copy-paste code, like to just do that? That's kind of weird. Maybe we can abstract that out? Holy shit. Let's introduce a notion of literal tokens. And by literal tokens, I mean the tokens that you interpret literally, right? For instance, you have a token open parent, and if you encounter open parent in the code, that's the token. It's literally that token. It's not like very vague, like a string, right? Because string, it could be any kind of combination. It's kind of like a very fuzzy, very vague token. It says starts with quote, double quote, and ends with double quote, but within them you can have all sorts of things. It's not like literal, right? But you have a literal token. Open parent is open parent, goddammit. It's literal token. And we have majority of the tokens like that are going to be like that. Right, so let's introduce the notion of a literal token. So what I want to do, okay, I want to create a structure. Let's call it a literal, maybe literally token. Let's call it literally token. So in here we're going to have is the name, right? So the actual name, or maybe the actual text of the token, and its associated kind. Right, so basically, if you see this combination of characters, assign that specific token kind to that. You know what I mean? Right, just assign that specific kind. Right, and let's just have a global table of literally tokens. Right, let's call it literal. Okay, so literal token, literal tokens, and we're gonna have an array of them. Right, so that's what I like to do. So, and for instance, I have a text. If I encounter just an open parent, the kind is going to be token open parent. If I encounter close parent, the kind is going to be close parent. What else do we have in here? Do we already have something? So open, preproc and valid, that's kind of fine. Okay, so, and for instance, if we want to support curly braces, right? So this is going to be open curly, and this is going to be close curly, right? And down there, we're going to just have a loop that iterates through all of these things, right? And if we want to add another like literal token, we can just add it there, and it will automatically pick it up and stuff like that. Sounds good? Sounds Gucci? Sounds Tamaguchi. Okay. So we also want to know the like amount of elements of this array. So let's actually introduce something like literal tokens count, which is essentially size of literal tokens divided by size of literal tokens 0. Right. So literal tokens there, and I'm going to put it in here. And so essentially what we're going to do in here, we're going to remove all of this stuff, all of this repetitive stuff with just a single loop that iterates through the literal tokens, size I. So all of that stuff in here up until here is going to be deleted. And it's going to be replaced with the loop that we're currently implementing, right? So literal tokens count plus I, right? So, and then and here's an interesting thing. So for now, literal tokens, they start with, they consist of a single single character. But what if we're going to have multiple characters, right? So for instance, think like this is a separate token. This is a separate token, but if like a single one. But if you put a space in here, this is going to be treated as two separate tokens. So there is a little bit of a complication in here, right? So as you can see, tokens are like very much space sensitive, depending on like on kind of tokens and like what space is between them. It can be tokenized completely differently. It can be tokenized completely differently. So what do we want to do? What do we want to do? We want to have a function that can check whether the Lexer, the content of the Lexer, the current content of the Lexer starts with a certain prefix, right? It's kind of similar to what we did on the previous stream with the editor, right? So editor, yeah, starts, yeah, it's kind of that. Like I want to implement something like that, but for the token, for the tokenizer, you know what I mean? Something like that, but for the tokenizer. Let me see what we have in here. All right. So Boolean Lexer starts with. So we provide Lexer, and we provide the prefix. Right. We provide the prefix. How are we going to be doing all of that? How are we going to be doing all of that? So I think I'm gonna steal this code, believe it or not. Yeah, so because the first thing we do, we calculate the length of the prefix, right? And then if the length of the prefix is equal to 0, that means it always starts with the prefix. Like any strings always start with an empty prefix, that makes sense. Then, what do we do? So this is a line, some other stuff. And if I take the cursor and add the prefix length +1, it should be less than the end of the Lexer, essentially. So essentially, if it's greater or equal to the Lexer content length, this is straight up no. That means the prefix is bigger than whatever content we have. It doesn't make much sense. And after that, we just iterate through the prefix values, right? Through the prefix values. So this is basically content L cursor plus I. And if it's not equal, instantly return false, otherwise we return true. Okay, so yeah, some of the code that we used for the previous highlighting mechanism can be reused in the tokenizer, which is kind of nice. I really like that. So let's try to compile this entire thing. It doesn't really compile because, yeah, so first I need to finish the implementation of this thing. So essentially, if Lexer starts with, so this is the Lexer, and literal token, right? So this is a literal token text. If the Lexer starts with this specific literal token that we found, we have to do the following thing. We have to set the token kind to the literal token that we found, then increment the text length to the length of the text of that token, right? strlen. Might as well save this thing to the text len, right? Because we're going to be reusing it, I think, at least 2 times, right? Because we also need to increment the cursor by that thing. And then we should just return return the token. So I'm not sure if like chop character is important here, right? So it's only gonna produce an error if there is new lines within this thing, but having a literal token with a new line is kind of weird. Right, so maybe I'm gonna put it to do in here. So note this code assumes that there is no new lines in here, right? So we're kind of making like a very bold assumption, but maybe that's fine because like it's kind of difficult to imagine such situation, but it's kind of important to keep that at the back of your head. Right. Okay, and that should be it, right? So we just like can add more tokens in here, and this copy paste is just replaced with a single loop, right? So let's actually go to the compilation errors. Let's go to the compilation errors, and we need to add more tokens in here, right? Let's go ahead and do that. Lexer.h. So this is going to be curly, right? Curly, open curly, close curly. Here we also probably have to add the names. Maybe I should replace this thing with an array as well. So here's the curly, here's another curly. Right. So and let's go. So it's still compiling, but it's producing some warnings and stuff like that. So here's the string. What else do we have? Okay. So as you can see, it is working, and it is tokenizing and classifying things correctly, more or less, I think. So as you can see, open parent, close parent, open curly, close curly, but it does not recognize numbers and the semicolons, right? But it's super easy to add semicolon, right? So semicolon, colon. So then in alexa.c, we're just doing the following thing. Semicolon, right? So this is a semicolon, and if I try to run this thing one more time, it's going to kind of understand, but token kind, yeah, I forgot to add a token kind semicolon. That's actually kind of cool, right? So it caught this kind of situation. Semicolon. It actually caught that, right? So, and we have only one invalid token, which is a number, which is also super easy to tokenize as well, right? So, isn't that cool? Isn't that cool? I think it's pretty freaking cool, chat. What do you guys think? Very cool. I also think so. So it's kind of like already done to some extent, right? It's already done to some extent. We can try to plug it into the renderer, right? So I don't really want to implement like literally everything, because it's not going to be, you know, very productive. It's better to take whatever like little tokenization that we already have, right? Like a little tokenization we already have, and just plug it in, and then keep extending the tokenization and having it connected with the renderer already. You know what I mean? Having it connected with the renderer already. So, but the thing that I didn't implement here yet, is essentially the calculating of the position, right? So because the token doesn't really have a position, right? So this is going to be Lexer.h, and this is what we have in here. And what I'm thinking is that maybe we should keep track of the position. Maybe we should keep track of the position the same way we keep track of the line and the beginning of the line and stuff like that. Though, with the way we render things right now, we assume the regular height of the characters, right? So that's basically what we do. Maybe we can do a similar thing, right? Maybe we can do a similar thing. And essentially, yeah. And essentially, yes, so I have an interesting idea. So here is the text, right, and here is the position. I might as well do it like this, I suppose. Token position X, right, so token position X. I take the line and multiply it by the whatever we have like in a free glyph height thingy, right? So free glyph font size, right? And the way we actually use it right now in the code, yeah, I just take a row, and I multiply it. I even not only take a row, but actually take a negative because we go down, right? Because we go down, and this one is basically like a line. So that's basically the position X. The position Y is rather interesting. I mean, it's actually Y. I'm sorry, I'm an idiot. I'm already getting tired. So the position X initially should start with 0, but it's already initialized with 0, so I don't have to really worry about it too much. Yeah. So this is where it is kind of tedious, right? Because we have to keep track of the current X of the Lexer. We have to keep track of the current X, float X. I'm not really sure how to call it, but I'm gonna call it X. And essentially, as we chop a character, we increment its X by its width, by the width of the character. So here I already called it X, but I mean it's under the namespace of the Lexer. Right. So essentially what I can do, I can take the X and I can increment this thing by the metric. So I have to go to the atlas. Right, I have to go to the atlas, and the atlas is this. Right. So in atlas freeglyph.c, right, what we do, we just add the metrics. Yeah, we just add the metrics of that thing. So X and Y, this is position within the coordinates, I suppose. I don't remember what it is, but I suppose I think that's what we have to increment it by. Yeah, that's what we have to increment it by, and then reuse it. So I think I want to make a small break, chat. I think I want to make a small break because now what this means is that the Lexer should also be aware of the atlas, right? It should be aware of the atlas, so we have to pass it somehow. We can't really pass it as an argument because it's more of an internal function. But maybe one of the things we can do in here is keep track of the free glyph atlas in here somewhere, right? So, and accept this thing during the construction, right? So then later we can actually properly use it. Right. So because it's kind of difficult to, just by knowing the coordinates like in characters, to find the coordinates in screen, right? Even though we're using monospace font, so it should be fine, but if you switch to non-monospace font, it's kind of gonna be, it's not gonna work, but we have to like design everything around the idea that you can use any font, right? So we have to design around that idea. So yeah, let's make a small break, and after the break, I'm gonna just go through implementation of this entire thing, and yeah. So the main problem here is basically figuring out the positions on the screen for the tokens, and after that, you can just feed the tokens into the renderer and tell it just render those things there. Should be pretty straightforward. Yeah. Anyway, so let's make some break. Let's continue. What we need to do. I think I want to try to compile and go through the compilation errors and just fix the compilation errors. All right. So because here we're supposed to provide the pointer to the atlas. In this specific case, yeah, it makes it kind of difficult to, you know, test like test that in a, what is it called? In a terminal, because we don't have the font atlas in the terminal, right? So because it requires like loading things up, creating textures and stuff like that, we don't really have that in here. So I'm gonna put a null in here, and I think I'm gonna create a Lexer that simply doesn't care about the atlas if you provide it null. Right, so it's called freeglyph.h. Since when? Wait. The fuck? Free? Since when it has icons like that? I don't remember it having icons. Like, holy fucking shit. Do I have like a properly configured text editor without a completion shit? What the fuck? I don't remember doing that. Okay. It was weird, but it is what it is. So Atlas, and what we want to have in here is Atlas. Right, so Atlas. Now we have it in here. Isn't it poggers, my dude? I think it's pretty fucking poggers. Holy shit. Free glyph atlas. Where's my T? Why is it still playing music? I'm gonna get copyright striked. Copy striked. That's what it's called. Okay, so in here, what do? We need to basically take the metrics of the character, right? So we only need to do that when this thing is not equal to new line. When the thing is equal to new line, I think we're gonna actually put 0 in here. Yeah, so that's the reasonable thing to do. But here, if it's not 0, we have to take the metrics. And the way we take the metrics, first of all, we figure out the glyph of the text, right? So essentially, the glyph index. So it's a text. The glyph index is literally this thing. Yeah, if it's x, if it's greater than glyph matrix capacity, we basically assign it to a question mark. Yeah, so that's what we're gonna do here. And then we take the metrics for that specific glyphs in there, right, that we pre-computed and stuff like that, of course. And then we want to increment x by that specific metric. That's what we do. And I think that is basically it, right? So, but it only makes sense if the atlas was actually provided, right? So, for instance, we're going to do if atlas is defined. If we provided null in there, we probably don't want to do that, right? And we'll probably have to do L atlas. So look at the amount of indirections in here. Look at the amount of indirection. My God, it's insane. Okay, so everything seems to be compiling, but on top of that, we also compute the position of the tokens, which is kind of poggers. I think. I personally think it is poggers. So the only thing we need to do now is to actually plug it into the editor, right? So let's actually go ahead and plug it into the editor. So the way I want to plug it into the editor is basically within the editor, on top of keeping track of the lines, I want to keep track of the tokens, right? Tokens for the highlighting. And we're going to have the following thing. We're going to have a tokens. Tokens is going to be the classical dynamical array, the dynamic array, the elements of which is basically a structure with 3 fields: items, count, and capacity. Right, and of course these things has to be size t. Right. And the items are tokens, right? The items are tokens. So we put it in here. And what I'm thinking is that we already have a moment within the text editor when we need to recompute the lines, which are basically also kind of tokens. What if we do a similar thing? What if we say, okay, when you recompute the lines, also retokenize the entire thing. Let's go to the editor, recompute. Man, this is actually too fucking simple. What the fuck? Okay, so where do we do that? Here it is. Okay, we recomputed the lines, and here we're gonna do another thing. We're gonna create the Lexer out of the text, right? So this is gonna be Lexer, Lexer new, and we have to provide the atlas. Do we have the atlas though? in the editor itself. We kind of don't, and this is something that we'll have to do. Yeah, man. Okay, so that means we need to store the atlas within the entire thing. We only pass the atlas when we're rendering this entire stuff, which can become a problem. Which might become a problem. So yeah, let's do the following thing. I'm gonna do free glyph atlas. Atlas becoming kind of invasive, so a lot of parts of the code need information from Atlas, which worries me a little bit, but maybe that's fine. Maybe that's basically where the architecture converges to, so maybe that's fine. So I'm gonna keep modifying it like that and see if it's going to work or not. Okay. So in the editor, we create the Lexer. Lexer wants to have the atlas. So here's the atlas. Then we take the data, the items of the data, and the data count. Right, so data actually stores the character, the actual text. Right, and since we also keep track of the tokens, so the editor, we take the tokens and we reset the tokens to 0. Right, so this is basically the tokens now. And now I'm going to do the following thing. So here's the token. Maybe I'm going to even do it like that. Lexer next. I provide Lexer. And while token kind is not equal token end, we keep adding that token to the tokens of the text editor. Right, so here's the tokens. And we add that token and we repeat that process until the end. Right. So that's basically it. So this is the entire re-tokenization. Cool. So we have here, so this is the token. We don't have a token, so we have to include the Lexer in here. Right, Lexer in here. Okay, that's cool. Okay, so we're still doing the test thing, right? So I probably have to get rid of the testing code and just use the actual production code and see if it still works, right? So we need to see if it still works. Okay, so everything seems to be working, everything seems to be twerking. We didn't really break anything yet, which is super nice. So the next thing we need to do, so editor, when I'm initializing the editor, so here's the editor. Where do I use the editor for the first time? So I recompute the lines in here. Maybe what I have to do is I need to first initialize the, what is it called? The free glyph atlas, right? After we initialize the free glyph atlas, I take the editor and I set the atlas to it, and now recompute the lines. I think that's what we need to do in here. Okay, so let's recompile and see how it goes. So there is a little bit of a concern that I almost forgot about, is that now we never have to directly do cursor +1. Right. Because when we chop a character, as we do cursor +1, we also need to recompute the position and stuff like that. So I think I need to make sure that I never call the cursor +1 directly and always do that through the chop character. Cursor plus. Okay, so this stuff should never happen, in my opinion, and this stuff should never happen as well, and this one is never happen as well. So this thing is happening, so we're not modifying this thing. This one within the chop character, this is fine, but this one is a little bit interesting. Okay, so how can we even do that? I suppose we can just do something like size ti, but this one is going to be j less than text length plus j, and it's just Lexer chop character L. Right, so we just chop in the character one by one. It's not particularly great, but it might be correct. So maybe the chop character should actually accept length, like how many of them do you want to chop? Which is a good solution, actually, because I feel like we don't really need to return anything in here. I don't think this thing should return anything, right? Because it's not particularly useful, because we always check for the character first anyway through the L content, right? So we first check it like that anyway, so it doesn't make sense. And it would make sense to actually just provide the length, like how many of them do you want to chop? I think it's reasonable, right? I do think it's reasonable. So, and essentially that means I can just wrap this entire thing into that. And it will make it easier to just say, okay, so I know the length of the token that I want to chop off. I can just pass that length and forget about it, and it's going to update all of the necessary coordinates for me automatically. I think that's a good thing. I really like that. Okay, so it means I have to repeat this stuff multiple times. I don't need to return anything. Okay, so here I just check that the L cursor is less than content. I could have actually just checked for that a bit earlier in here, so I never have to assert in here, but I'm a little bit lazy, so get rid of this assert by checking the length of the chopped prefix up front. Right, so similar to how we do that with the prefix, but I feel like I'm a little bit lazy right now. Okay, so that updates the metrics, that also updates everything in here, and that should be fine. Okay, so let's actually go ahead and go through the compilation errors in here. Okay, so when I trim left, I can always say just 1, right? So this is going to be just 1. What's the next thing? We chop in things by 1, and here we're also chopping by 1. It would be kind of nice if C had default parameters, so I could do something like by 1 by default, because that's usually what you want to do, but it is what it is. Okay. And in here, right, so that's entirely the reason why I introduced that stuff. I can now do text len. That's it. So because of that, maybe it makes sense to call it chars, but I'm gonna change that later, maybe. We'll see. And seems to be compiling. That's cool. Unused. Okay, is that it? It feels like it. So oh yeah, I still need to get rid of the things that update L cursor. Yeah, for example here. And Lexer chop character L1, that's totally fine. And here we do it like that, and then we just don't do this thing. All right. L cursor, we can refer to L cursor just to check things around, but we better not update it. Right, so updating this thing must be done through a centralized place, because it may require updating the coordinates and stuff like that. Right, so I think that's quite important. Okay, so I guess that's it. So the next step is to actually go into the renderer, right, and just render all of the tokens. That's what we want to do. We just want to render all of the tokens. We have quite a lot of this stuff in here that renders the text, right? So, which we probably don't even need anymore, believe it or not, right? So we have 73 lines of code that render the text. I'm not really sure if we need that anymore. So I'm gonna just like factor that out. I mean, comment it out. That's what I want to say, not factor that out, but comment it out. Right, because what we have to do now, we have to just iterate through the tokens, right? We just need to iterate through the tokens, and depending on the color of the token, we just have to render them differently. So to do that, we need to set a shader for the text, right? So let's set the shader for the text. And then, of course, we want to flush that shader afterwards. There we go. So we're setting the shader for the text, and let's iterate through the tokens. Right, so this is going to be like this. Editor, yeah, so it's editor, tokens, count, plus I. Right, and within each individual token, right, these are the tokens that we tokenized, right? Items I. So within the token, we have a position. Now we have to use that position to render something there. Okay, go. How are you guys doing? I'm already streaming for more than 2 hours. My God, it's kind of interesting. Like every time I'm doing anything, even remotely simple with the tokenization, it takes a lot of time for some reason. I don't know why. Even though the concept is extremely simple, it's just like, yeah, for some reason it just takes a lot of time. Okay, so how do we render the text? So we just do free glyph measure blah blah blah, and the way we do that is rather weird. We need to keep track of the position, right? So we need to save the position somewhere here. So this is going to be the token position, and then we'll have to forget about it. So what do we do? Token text, token text length, and here's the position. Surprisingly, that is it. It's just we also have to do that with a different color. By the way, where do we put the color? Oh yeah, and then we render a solid rectangle with a certain color. It's a selection. I'm sorry, I'm an idiot. Same with getting up from bed in the morning. Simple process, it takes a lot of time for some reason. Yeah, it is kind of similar. I forgot, how do we specify the color? Shader for the color, shader for the text. Oh yeah, here, like we specify the color in here, right? So let's say that I'm going to use the color white. Yeah, so this is measure. I have to use render. And here's the color. We're just using white color in here. Okay, so token text. It didn't really like the token text. Incompatible pointer type. What are you talking about? So let me find the render line sized. Yeah, so you have to provide this thing. So first comes the atlas, then simple renderer, then the text, then the length, position, and the color. Makes sense to me. Okay, go. The fact that it still renders is already great. Okay, that's cool. Oh. Okay. Made. So you can clearly see when it didn't update the position of the token properly. I mean, it works exactly as I would expect, right? So it even has the bugs that I expect. Right, with the symbol, when we chop a character, right, when we chop a character, we have to sort of update it like that, but something's weird. Yeah, that's basically the problem. We have to set the X of the Lexer. That's what we forgot. Right, we have to set the X of the Lexer. But it already like recognizes the tokens, right, which is super nice. Yeah, there we go. So now it just positions them properly. Okay, so, oh, it doesn't update the camera as well, right? So this is another problem. Another problem which I can probably fix for now with a weird fix, but nonetheless. So max len line len, right? So this is a max line len, and so for now it's always going to be equal to fix temporary zoom epic zoom camera action. So I'm gonna just do it like that. Okay, so yeah, so essentially what we have to do, depending on different tokens, we have to provide different colors. That's it. So we can already recognize the tokens. So that's what's cool about all of that. So here's the color, right? Color, and if, for instance, token kind is equal token preproc, we can set it to something else. We can just set it to something else. For instance, we can set it to red. 001, right? If the token is that, the tokens are going to be just with this color. So let's see how it works. So here's the regular thing, but then I define include, right? Everything up until the end of the string is going to be red, and then everything's going to be fine again. So let's introduce something even more interesting, right? Let's introduce so-called keywords, right? Because that's what we wanted to highlight all along, right? So how are we going to be introducing them? Let's introduce token keyword. Here's the token keyword. In Lexer, we have to also define the name for this thing, right? So this is going to be keyword, and this is also going to be keyword. The thing about keywords is that they're symbols, right? They're symbols, but they're special symbols. What I'm thinking is that as soon as we parse the symbol, what we want to do, we want to compare it with one of the keywords, and if it's in the list of the keywords, we're going to change the kind to the keyword. You know what I mean? Right, so we already have a list of keywords. Here they are. So here are the keywords. I might as well actually just copy paste this entire shit and move it into the Lexer. Right, now we're gonna have the keywords. So what we want to do, we want to after we took the symbol, we want to iterate to the keywords. For size I less keywords keywords count. I think that's what it is. Right. Let's just go ahead and compare things. All right. So, but the thing is a little bit more complicated. So we need to have a keyword length. So strlen keywords I. So we know the length, right? So we know the length in here. Now, if keyword length is equal to the token text length, that means they're probably equal to each other, and we can use something like maybe memcmp to actually do that. Right, so the problem is that we're comparing null terminated string with a sized string that doesn't have a null termination, and because of that we have to use memcopy. Memcmp, not memcopy. So we're going to take the keywords I and the token text, and we're going to provide the keyword length. And if it's equal to 0, we found the keyword, and we basically say, okay, this token is a keyword, and we break out of the loop, right? So essentially the idea is the following. We successfully parse a symbol. We check, is it a part of any keywords? If it is, we reclassify this thing to a keyword. And now we can distinguish keywords from regular symbols, and now we can highlight them differently. So that's kind of cool, right? Hopefully, we'll see. So let's recompile everything. Okay, so this is the preprocessor shit, and then here with that. Okay, so let's go to the editor. And we can even start doing a switch, right? So token kind, if you have token preproc, so red for a preprocessor is kind of weird, but I'm gonna keep it for now. I'm gonna just keep it for now. We're gonna change it later. If it's a keyword, we're gonna use yellow color. Okay, so this is a simple table of like colors. So this chunk of code is basically the color theme of the text editor, right? Because we are assigning different colors to different tokens. And you can even maybe create a simple text format, which is basically name of the token, its color, name of the token, its color, right? And you can just parse it or something like that. Or maybe JSON. People like JSON. People keep asking me, can you do the JSON? For some reason, it's important for people to use it specifically JSON format. I don't know why. I personally don't care. Like, I mean, computers don't care either. The only people who care, the only one who cares about the specific format is humans for some reason. Okay, so we don't have these things, so maybe I'm gonna do default in here and just like an empty thing. Oh, it's a web. Oh, that explains it. Okay, it's web developers. It's just web developers being web developers. Okay, so now let's put some keywords. Ooh, look at that. Right, so you have int main, but if you remove a space from here, it's a single word now. Isn't that cool? Isn't that cool? Dab, 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 dab. Holy fucking shit. And it worked properly because it tokenizes shit. We can try to open the source code of this thing. Oh, look at that. This is so cool. This is bash file, right? This is bash file, but we're using the tokenizer, C tokenizer. And it kind of works to some extent, right? It kind of works to some extent. At least it recognizes the preprocessor thingy. Oh, the selection actually doesn't work anymore, right? The selection doesn't work, but I think we can do something about that. So let me, yeah, boy, yeah, boy, yeah, boy. Okay, so I'm gonna put this thing somewhere here. Yeah, so now we should have selection. Now we should have selection. If I put some shit in here, yeah, okay. So that's fine. It's not really that difficult. Boom. Yeah, that's so fucking cool. Now, let's open the source code of the editor itself within the text editor. Okay, so we can see the preprocessor shit, which is fine. The comments are not tokenized properly. This is probably something that we want to address at some point, but the keywords are fine as far as you can tell. So static, some other shit. Maybe we should tokenize comments. Let's give it a try. I'm gonna go ahead and tokenize comments. Lexer.h comment. All right, and it's kind of similar to tokenizing preprocessor right now. It's only that the preprocessor doesn't handle new lines. Proc should also handle new lines. There we go. So in here we have to do Lexer starts with // right, and then what do we want to do? We want to do Lexer chop character, and we want to chop 2 characters. Right, we also want to set the kind to comment, right, so this is the comment. And while we don't have until the end of the line, we keep chopping the characters. We just keep chopping the character, and that's it actually, that's literally it. So what we're gonna put as a comment in here, so comment. Usually I use like an orange color in here or brownish color. So maybe let's put it like half of this thing. Right, maybe it's gonna do something. All right. So we have some code. Right, so here's the code. And then I want to comment out something. It seems to be working, but something went terribly wrong in here, as you can see. Yeah. I don't know what exactly, but yeah. Ooh, that's... Oh, I think I know why I'm an idiot. I should have not removed these 2 things in the Lexer, because it would have worked automatically anyway, I think. Yeah. It's kind of weird that I don't have to do that, but sure. Sure enough. Right, so yeah, that's fine now. So and the reason it works automatically. That's so cool. Okay, so let's actually open the code. So here's the preprocessor shit. Here's the comments. You can clearly see the comments now, right? The comments are properly handled and shit. Right, so it works. So we can comment out, and as you can see, it commented out up until then. So it's cool how if you have like a proper tokenizer, like coloring the text becomes trivial, right? Because it's basically tokenization. Do we have numbers? We can also try to support numbers at some point, but I don't know. Yeah, that's cool. We don't support strings. We can also try to support them, but supporting them means supporting escaping, but I don't think we use much escaping here at all. Right, I don't think we use much escaping in here. Okay, let's try to maybe use some specific colors, color them, right? Use some specific color them. The problem with the color them, in my case, is because all of the colors are four-dimensional vectors, like floating points vectors, right? So I need some sort of a function that would help me to convert hexadecimal codes that, because what I want to do, I want to take the color theme of Emacs and use it there, right? That's what I want to do. So, but all of the colors in here, right? So Rexim, Gruba, Daka, yeah, they are hexadecimal values, right? So as you can see, they are hexadecimal values. So I need to convert that to floating point vectors and stuff like that. Does the tokenizer run for every character type? Yes. And this is on a 10 years old laptop. This is on a 10 years old laptop from which I'm also streaming. Computers are insanely fast. You have no idea how fast computers are. It's fucking insane. Especially when you get rid of most of the abstractions, most of the redundant shit, and just take the pure computational power of the computer. It's fucking insane. Right. All right. So what do we have? So where are we gonna put this kind of stuff? I wonder, by the way, I'm actually doing 2 tokenizations per character type, right? Because first I tokenize by lines, and the second tokenization, now we added the second tokenization for colors. So my usual test that I like to do is to have like 100,000 lines and see how it performs with that. Well, it's not going to work for that specific editor because we also have to do the rendering. Okay, so let's actually see if it's going to kill my computer, right? Oh shit, it's not going to... The renderer is going to crash it even further. Like even before that. Goddamn. Oh, yeah. So because a renderer is kind of limited, so it cannot render more than like 600,000 of vertices. So if I try to render more, it's gonna just basically crash it. So this is safety failure. I'm gonna work on extending it and see how fast we can go. Anyway. I'm not worrying about the performance right now. I'm just figuring out what I need to do. Okay, so I need a simple function. I need a simple function which takes the hex code, right? So hex to vec for f, right? So you insert it to t color. Very simple function. And what we're going to do, so we're going to start with red. So red, we're going to parse it the following way because I'm going to be typing it manually. Red, red, green, blue, A. So that means I have to shift it by 3 bytes, 3 multiplied by 8. So I'm shifting there and then I'm masking it, taking this entire thing. So I've got red. Then I want to take the green, it's kind of similar by shifting by 2 bytes, then blue by 1 byte, and then A is by 0 bytes, right? I'm just masking it like that. So I have RGBA. Cool. So to convert R to value from 0 to 1, what I have to do, I have to divide it by 255 but in floats. All right, and that's basically the result. Right, so the result is this. Result X is going to be this. Y, Z, is it? I don't remember actually. What are the? It's W. Okay, so it's W. There we go. So, and then we just return this thing. Cool. Cool. Cool, cool, cool. Now, what I can do is switch token. So here, I can just assign the following thing. So we have a preprocessor, and for the preprocessor, what do we use for the preprocessor? Preprocessor, we're using darker quartz. And the value of the darker quartz is this one. So this is what we use for the preprocessor. So that means I can go and just convert it hex to vector f, and there we go. I want to do something like this. So this is preprocessor. For the keyword, we use the yellow color, and the yellow is this one. So now I can just like directly take those things and use them. Hex to vector f, right, x, like this. Cool. Comment, as far as I know, comment is brown. This brown color in here. Hex to vector f, cc, boom. Okay, so we're already using colors from the from my theme. It's not really my theme, but I adapted it to the color theme of thingy. Okay, so I was complaining about unknown vec for f in a common h. Okay, so what I just need to do, I just need to include LA, which stands for linear algebra. It also doesn't know anything about stdint, so I mean, what does it say? Unknown type uint32. So that means I want to include stdint because they are type defs, if I'm not mistaken. Yeah, okay. Okay, so this is cool, actually. Right, so this is preprocessor. Then so the background is kind of off. Okay. To do hello world. Yo, this is so cool. Holy shit. Okay, so where do we set the background? Yeah, the background is off. Okay, so let me try to do the following thing. Vec for f, background. And I know for a fact that the background is this. Right. Let's go BG. BGX, BGY, BGZ, BGW. So we set the clear color like this. Okay. Okay, can we compare this shit now? Okay. Well, I mean, it doesn't handle this part. You know what I mean? It doesn't handle this part, but it's kind of... That's so cool. So it does look now like my editor. So we can have print hello world. Right, so print hello world. PrintF. Strings! We're not supporting strings. God damn it. Okay. Oh, let's take a look at this thing. The rainbow doesn't really look that great on this background. So. Okay, just a second. So you want to try this on with a high refresh rate monitor. Just a second, I'm gonna finish. I think the thing we need to do, we need to add support for the strings. All right, so we're not gonna have the, what is it called? Oh my God. The escaping, right, but that's fine, I can edit later. Okay, so if L content, L cursor is equal to this thing. Why Emacs? Okay. String. Token string should also handle escape sequences. And one of the things I probably want to do here as well is just chop one, then while I'm gonna keep copy pasting this thing. While this thing not equal to this thing again, we're gonna keep doing that, and then we're gonna return. All right. I think that's it actually. Okay, it is working, and now in the editor, we're gonna have a string, and the code for the string is this. It's green, right? It is green. So now let's go ahead and try to write a hello world. Let's write a hello world. So it's gonna be that. So this is that. PrintF. Fuck. Hello world. Right. So that didn't really work well, but I wonder why though. Okay. So let me think. Why is it like that though? Is that because of the new? Oh, I think this is because of the new line. Yeah. All right. Not equal to this thing and not equal to the new line. First try, Pog. Yeah. I think this is because of the new line. Though it is not particularly correct to lex it right now like that, but we're not lexing to compile anything. We're lexing specifically to highlight things, and this is kind of a different purposes for the lexing, in my opinion. In my personal stupid opinion. So printf hello world. Yeah. So don't particularly know what is so wrong with all of that. So we set the position in here. We set the position in here. Ooh, yes, that explains this shit. Okay, bro. I feel like we have to compute the length differently. You know what I mean? Something like token text len should be equal to L cursor minus the beginning, but we also have to keep track of the beginning though, right? So I can do something like L content L cursor pointer minus token text. And that way I never have to actually increment the length, like this kind of stuff. Yeah. And since they're 1 byte, so that should be fine. But I mean, it's pointers. Oh, I'm an idiot. Though, I actually did it for the comments, which might not be a bad thing for the comments. Right, so I'm gonna keep it like that. I feel like I have to do that for everything. Alright, for all of these like stringy things, right? So by stringy things, I mean right now preprocessor, comments, strings, like everything, like, you know, that has like this variable weird length. I think I have to do this kind of stuff for all of them, right? So essentially, I know the beginning and I know where it ends, and I just subtract one from another, and that way I don't have to worry to forgetting to increment something. You know what I mean? So that's kind of a good thing. That's kind of a good thing. Okay. Okay, so this works. This still works, all right? And that was kind of weird why it was highlighting those things. Huh. It looked kind of nice, but I mean, this is not what I wanted. At the end of the day, that's not what I wanted. 1, 2, 3, 4, return 0. Right, so hello world, and then I'm gonna do printf hello world, new line, boom. Isn't that poggers, my dudes? Isn't that poggers? I think that's pretty fucking poggers. So let's go ahead and commit that, I suppose. Let's go ahead and commit that. So this is basically it, and we have a mechanism to which we can keep adding more and more different kinds of tokens, right? Right, and eventually implement a whole tokenizer and stuff like that. We can color open and close parents, for instance, right? So we can go ahead and color all of these things, right? Not everything in here is particularly useful, I think, but maybe some of these things are useful. Oh, we'll see. All right. So there's some stuff that probably needs to be cleaned up in here, because, for instance, we don't need this stuff anymore, right? Rendering based on substrings and stuff like that. I'm gonna keep it in here because there's some things that I have not finished yet. I would like to finish them. Hope I didn't remove anything important. Yeah. Okay, so I didn't remove anything important. Let me see. Let me also open this thing in here. Right, so here's the code. And it supports the strings. It's gonna break if I try to do something like this, as you can see. Right, so the proper tokenizer has to take these kind of sequences into account. Right, and it should continue like tokenizing this thing until the end, but it's relatively easy to add, but I'm not going to do it right now. So yeah, that's pretty cool. I really like where it's going, and it feels like my text editor almost. Maybe we can even use Yosefka or something like that. So let me find. So we even have something like fonts. Oh yeah, here's Yosefka. Term. So what kind of stuff do we have? Do we have a regular? Oh, regular TTF. Okay, I'm gonna copy paste the Yosefka to here, right? And I'm going to just use it. I'm in the text editor. So Victor. Where is that? Okay. Ooh, bruv. Okay, I wonder if it's going to work. We're about to find out. It does work. Look at that. It's so cool. Yeah. Yeah, so there's a little bit of like weird stuff with the cursor alignment. I'm aware of that. I'm just like don't care about it right now. Yeah, that's cool. Man, this is so cool. So if we go to here, I think I'm gonna leave a IOZF code. I think it's kind of cool. This is a shell. Oh yeah, now the strings work in shell as well. There we go. So the shell script. You can already kind of use it because a lot of languages use double quotes for strings anyway. Right, so it kind of works for Bash as well, but in Bash we don't have FI, right? So we could probably add FI to list of keywords. We can probably make a configuration option where you could say, okay, for this language, these are the keywords, and it's going to basically treat this array as dynamic array, and maybe user can just add or remove things from here, like for different systems, different languages and stuff like that, right? Just like different ideas. Oh yeah, so the previous highlighting, yeah, this is actually kind of funny. So the previous highlighting considered combination of characters door as a separate keyword because you had the keyword do and or, and they were basically glued together to form a door. We can even take a look at that, right? So I think if I stash whatever I have in here, we have a previous version, right? And yeah, so a new keyword in C just dropped called door. So our new Tokenizer, like highlighting system, actually takes that into account. So you can't have door anymore. Right, so you can have do or, but you can't have door. Right, so only that. Only that. So that's what it was all about, my friends. That's what it was all about. So let's do a committee and maybe possibly even pushy because people are urging me to commit that and push that. I'm gonna also commit this thing. Okay. Implement Lexer based syntax highlighting. There we go. I'm gonna push that right into the repo. What's the RAM usage for your text editor? Who cares? Just buy more RAMs. It's 2023. Come on. So it's dirt cheap. Freaking dirt cheap. So almost ready to work on the editor itself. Yeah, so before I can use this editor to develop itself, I think I need to fix the problem with the camera, right? Because the camera is kind of like vomit inducing. I am aware of that, right? So I'm aware that's a little bit vomit inducing. And I need to think about like a better AI for the camera. I don't know, that's the trendy word everyone uses these days regarding like whatever it means. Right, we need to have a better AI for the camera so it's not that vomit inducing. So then I can work on that. So for instance, I don't like the fact that the camera is centered at the cursor because you have like a empty half of the screen. It's kind of cool that it follows you around, but then half of the screen is not visible. It's cool when you only start typing, you know what I mean? When you just do that. It's cool when you have nothing. It looks cool. But as soon as you have something and that something is actually significant enough, the camera should actually kind of like minimize the amount of empty space or something like that. You know what I mean? Right, so the behavior of the camera should be more sophisticated than it is right now. So to make it look interesting and good and stuff like that. Like for instance, for now, it's kind of totally fine that it's centered at the cursor, but then later, as you have more code, it becomes like unusable, right? Because if you open like something actually reasonable, right? So the source code itself is just like, I don't see half of the code and half of the screen is empty. How is that cool? It's not cool. It's only cool when you have no code. It's a text editor that makes your code look cool when you have no code, right? So that's pretty interesting. It already looks kind of nice with the highlighting and like stuff like that. I really like that. Yeah. So I had also a couple of interesting ideas for animations, right? For instance, it would keep track of the current token that you're currently typing out. For instance, like it keeps track of this current token, and this token is symbol right now. But as soon as this token becomes keyword, it would just like make the token sort of explode with particles, like, oh, you made a token, you completed the fucking sequence, holy shit, an achievement pops up or something like that. And for instance, it would keep track that you're currently on a keyword, and you remove a character that transitions that from a keyword to being a symbol, and it's not gonna go to white right away. It's gonna slowly fade out. You lost the power of the keyword. It's not a keyword anymore, and it's just like it just fades away into just a regular, a boring symbol. So that's basically the idea. It's just like and there's particles, and particles have a gravity, and they just fall down. It's like, holy fucking shit! I just guessed a keyword. My God. So that's kind of weird shit I have in my head. So anyway. Yusu. All right. So I think that's it for today. I'm already streaming for 3 hours. Holy fucking shit. How am I supposed to put that on YouTube? Nobody's gonna watch 3 hours on YouTube. I mean, people barely can watch 5 minutes of YouTube shorts this day. Right, so how you expect people to watch 3 hours of just me rambling? Anyway. We need RTX render for this editor. Well, I don't have a graphics card for RTX with RTX. Probably will never have. So. Dead Mouse is streaming something on a science and technology section. What the fuck? Oh, he's also a programmer, isn't he? He's just like writing his own shaders for like effects and whatnot. I don't know what he's doing with that. But yeah, I think, I'm not sure. Not 100% sure, but maybe. Should we rate him? I don't know. Probably not. Anyway, yeah, it's some sort of a shaders. Yeah, some shaders shit. Okay. Anyway, that's it for today. Thanks everyone who's watching me right now. Really appreciate it. Have a good one, and I see you all next time. Love you. Mwah.